All right. Hi, I'm Niels Bakker. I work for M6. I'll keep this a bit short because I'm a bit fluish, so I hope you can understand me in the back and everything. Put this mic more in my position. I'll be talking about generic scaling issues that we as M6, as an internet exchange, have run into during the past half decade or something. If you have a question, you can save them up until the end, but feel free to interrupt me and ask a question during the talk. So this is the basic traffic pattern statistics. Top slide is from February last year, the bottom one I just took. And the traffic pattern hasn't changed much, except the y-axis has grown from 160 to 240 gigabits.
It's worth pointing out there's a floating x-axis, isn't it? The zero floats.
Yeah. The zero isn't zero, just so you can actually see that there's a difference between day and night. This graph is a bit more interesting. Got a logarithmic scale on the left, on the y-axis. It's normalized traffic growth per month. That means that you take the traffic growth and you divide it by the number of days per month. And this is a linear fit to a logarithmic scale. So it's been exponential growth since '98. The average growth rate has been 7% per month. We don't expect this to change much. Video is coming, more services like that. Keynote has been about that. We've been managing this growth by, our members have been managing this growth, supported this growth by massively upgrading to 10 gig over the past 2-3 years. In fact, there's one member who will be connecting with a 5-port 10 gig aggregated link, so 50 gigabits per second. They will be able to send to exchange point members. This is the port growth. There's no 100 gig in here yet. Then again, the graph stops at 08, so there's not much point of putting it in there because it won't be there yet. Port growth is linear until something bigger happens. So the gigi ports growth is sort of slowing down now that 10 gig is really picking up. We have 260 plus members with 430 plus ports right now. The job we've set out to do is to build the infrastructure that people need to interconnect and get rid of their traffic, send it to their peers. In the next few slides, I'll go over the historic network layouts that M6 has used in the past half decade. We started in 1999 with 2 switches, one at Sarah, one at NICHF. Very simple model, but it has a few limitations. The switches run out of switch ports. It's not really enough for proper redundancy between sites. You run out of data center space too. There's too many people who want to connect, want to have their router on site. And yeah, it's pretty limited, obviously. I do think that Torix is right now at this stage and sort of comparable in a way. The next step M6 made was expanding to 2 additional sites in 2000 with a ring structure. And this ring topology didn't really scale well. The moment you have a lot of traffic between 2 particular sites, you have to upgrade the whole ring in order to sustain outages. So we were running spanning tree at the time, and edge site 3 and edge site 4 were quite busy. They're named 3, 4, 5, 6 for historic reasons. So there's a lot of traffic usually between 3 and 4 because they were historically the early sites. And we had to upgrade traffic. We had to upgrade backbone links in the whole ring in order to be able to be resilient against failures. So also spanning tree is a bit of a bad thing. The moment any change happens, then it starts flapping for a while. It may not stabilize. You get members trying to talk spanning tree to you, and one switch that has a lot of CPU, it has a high CPU load, can affect the whole exchange because spanning tree starts flapping and you have too many ports in forwarding mode. So in 2003 we moved to new topology with 2 core switches. All the edge switches where customers connected were connected to both switches with symmetrical links. So 2 times or 1 times 10 GbE to each switch. Members connecting with 10 GbE were connected via photonic switches to the core switches. We expected not much 10 GbE port uptake in the first year or so, and decided against adding a separate edge switch where we would connect 10 GbE members, because the edge switch technology didn't really run 10 GbE at line rate well. We managed this changeover from a ring structure to a dual hub spoke topology using photonic switches. These are basically glorified patch panels. You control them remotely and tell them to connect different ports to other ports. I'll talk more about that in upcoming slides. We also switched away from spanning tree and switched to VSRP. It's mostly comparable with VRP, HSRP, only then for layer 2 devices. So 2 VSRP speakers communicate and decide which one is master, which one is backup, and the backup puts all its links in blocking mode and doesn't pass traffic that it sees from there. And the moment the master disappears or its priority goes down or whatever, then the backup takes over and puts all its links in forwarding mode. So, the photonic switch. It's a glorified patch panel. It can connect any input port to any output port. So of each LC connector block, in is left and out is right. These are made by Glimmer Glass, and we've been using them since 2003. We have separate switches for customers and separate switches for our own backbone. This is how a 10 GbE member connects. We decided to move away from connecting members to one switch only, because any outage involving that switch would involve a lot of downtime for affected members. And in retrospect, this has proven to be a very good solution, because we've had our share of problems and outages and even 30-second blade crashes. But you don't really want customers to have an outage just because a blade crashes in the switch. And with the photonic switch, we connect 10 GbE ports to a photonic switch, and we have 2 topologies. And depending on which core switch is active, we connect them to the left or the right core switch. And yeah, it means we have quite some duplication in hardware, but it also means that you can work on half the network without having to take down any member ports. It has also greatly facilitated upgrades, in that we've been able to map customer connections to new edge switches that we installed without breaking their link and moving their fibers. We could work on the non-active part of the network, the backup part of the network, and then do a switch over to work on the other part of the network to finish the migration. And we've done several migrations this way. For example, the original introduction of 10 GbE edge switches, because we didn't have them first connecting ports to the core. And later also to upgrade the edge switches, we migrated from MG8 to Foundry RX16 switches, with hardly anybody noticing that. So 10 GbE core ports, brief history. As you see, there's quite some growth. A lot of members with 10 GbE aggregated ports, so 2 or even 3 times 10 GbE in a single bundle. Our current topology, we have 2 core switches. We will be moving them to separate sites, so away from Telecity to NICAF, where they are now. And we still have some upgrades to do that are already in this picture that have not been done. The Sarah switches, or actually this picture is correct even. The Sarah switches will be upgraded to RX16 in the upcoming weeks, so we'll be able to offer even more 10 GbE ports there. So what's next for internet exchanges such as us? Our current platform, if we stopped working on our platform tomorrow, then we would be able to sustain 127 10 gig ports. And we expect to reach that around that time frame. After that, we will have to have bigger switches. Of course, we don't stop upgrading switches, so this limit won't be reached. When we run into the limits of the amount of ports we can fit in the core switches, there will be 100 gig available, 2009, 2010 timeframe. We can take load of the backbone switch, of the backbone links from the core switches to the 10 gig aggregation switches by bringing high traffic, high volume members to core. There's some interesting work being done in the IETF called Trill, sort of spanning tree replacement, where information about what MAC address is behind what port is distributed via ISIS or different methods. It's probably not useful for us because we would need to interlink our switches. We would need to mesh our switches to a lot higher degree than we have right now. And that means that we will start adding again more backbone interfaces on switches that don't really have enough space by that time. Right now we can nicely fill our switches with about 103 oversubscription, and that works well. Yesterday Greg Hankins already said a lot of good things about the 100 gig standardization process currently going on in the IEEE, and I don't think I'm going to repeat that here. Yeah, another limit that is not on here is the current switches that we use have an 8-port trunk limit, can only trunk 8 ports. Foundry have told us that they will be bringing out bigger switches that don't have this limit, so clear upgrade path there as well. Okay, ahead of time.
Anybody got any questions for Niels? And whilst anybody is asking questions to Niels, could I get the 3 speakers for the lightning talks to come and at least sit somewhere near the front, and then we can get through you fairly quickly. Is there a question? Question on the right mic. Actually, Todd's first. Mr. Underwood, go.
Hi, Todd.
Todd Underwood, Renesas. So there is a brewing brouhaha of conflict around 40 gig versus 100 gig. And people in your situation and Mike's situation are pretty uniformly saying 40 gig is useless to me, it's not enough more than my edge, I have to have 100 gig and I have to have it right away. And there are a bunch of other people saying, yeah, but 40 gig is doable much, much sooner, and wouldn't that be better to focus on? Can you comment on where that is in the standardization and whether 40 gig would be at all useful to you?
Well, we already have 8-port 10 gig aggregated links, so we're already pushing 80 gigs between different switches. 40 gig would not help us much except save us 3 fiber pairs. And what we really need is 100 gig leapfrogging over the current technology. Traffic is doubling every year, and going from to 40 gig is just a past station. It's no use.
Okay. So so saving the pairs sooner, saving those 3 pair sooner, not good enough. It's just not going to make saving the 3 pair, going to 40 gig and saving the 3 pair.
Yeah.
By the end of this year.
Saving a few fibers is nice, of course. We can achieve the same thing using DWDM optics. They're becoming very affordable, and even in a metro area such as Amsterdam, where fiber is readily available usually, it is already becoming economically feasible to run DWDM with the standard 100 gigahertz spacing. 40 gig will just save fibers right now, and it's not enough. We already have 80 gig ports.
Okay.
Port
and Mike,
channels.
maybe you can comment on that from the links perspective as well.
Well, I have a comment that sort of seems certainly my understanding in the standardizations process is even to use the existing technology that people are using for, say, 40 gig SDH today, and be able to do Ethernet over that. You could probably do the encapsulations that Dave was talking about. But if you wanted to do it sort of native kind of WAN-Fi Ethernet type flavor at 40 gig, you've still got a lead time of a couple of years because you've got to deal with line encoding, acceptable bit error rates, what the SerDes look like, how you're going to get all this stuff onto the fiber, and into the optics, what the PHY looks like. You can't just basically take the 10 gig PHY and stick that onto a 40 gig optic. Was the
so
the
you're
wisdom
just saying
that came out of there. So there'd still be an enormous lead time.
So you're
It
just
could be
saying
like
you-
deliver
That's
40
really
gig tomorrow.
you disbelieve that there's a significant time advantage in the standardizations for 40 versus 100.
Exactly, because the IEEE process just takes a set amount of years. And Tatsili made this point yesterday as well during the peering BOF. If you now start a 40 gig group within the IEEE trying to standardize that, you will distract the 100 gig group, draining resources from that. Plus you will not deliver something that is needed right now. And finally, it won't be there earlier because the process takes just as long.
Okay.
It just actually probably be later.
Thanks.
And this parity between SONET and Ethernet, I think that's only happened twice, where 10 gig is sort of close to 9.6 gigabits per second, and 2 megabit E1 versus 10 base 2 over coax.
Okay, thanks.
Hello, Bernhard Krönung, P6 Frankfurt. Just two questions. One, if 40 gigabit ports would be available and you had to have enough backbone capacity, backplane capacity in the switches, would it overcome the problem of the 8-port aggregation limit? The other question would be, until which traffic level you will allow 100 megabit ports, because if there's something happening at multiple 10 gig ports, it maybe flood the 100 megabit ports, or even the 10 gig, the 100 megabit ports, even the 10 megabit ports you have at the M6.
The first question is kind of foundry specific. From what I understand of the architecture of the RX switches that we use, I don't think it'd help because the traffic managers are still 10 gig. For MLX and up, it's different because it's their own stuff. The second question I sort of interpret as how long will you continue selling 100 base T ports?
Yeah, how long will it be no problem to connect with 100 megabit to an internet exchange with this traffic level because of the chance to get flooded away by some strange traffic, or at least some up whatever traffic?
So the case where, say, a member connected at 10 gig is flooding ARP traffic, and yeah, we've seen that a few times. We rate limit ARP traffic and on unicast so that it doesn't flood out ports, and also that it doesn't choke the switches, because the big irons 15,000 still do that over the CPU broadcast. We've seen cases where Cisco routers have had their forwarding tables screwed and started sending traffic destined for one big peer to another peer's MAC address, which would then have like a lot more traffic than they used to have. I guess we'll continue selling 100 base T ports while people still want them. And yeah, there's a risk in that there's a 100 times traffic limit, but in the case of DDoS attacks, this disparity already exists in that you can get hit by more traffic than you can handle, and even with the 10 gig port, I'm sure it will happen soon.
Okay, thanks.
I could add a perspective to that actually as well about the flooding, and that's with multicast. In London at Links, we've got quite a significant push from the BBC because of their unique way that they're funded by tax, basically, rather than adverts. They are quite heavily involved in pushing out multicast IPTV content. We've got a multicast exchange with PIM snooping turned on. But if you actually need to receive any significant amount of multicast traffic from the BBC, you will actually need to connect to the multicast exchange at more than 100 meg. You will need a gig port to connect to the multicast exchange, because if you received all the BBC content, it will be well over a gig. already. So that's an
Go
interesting.
BBC.
So there you go. Maybe the guy from CBS needs to hook up with him. I don't know.
No, I don't send him the CV.
Hi,
Will,
Will
go on.
Hargrave, LONAP. Just wanted to echo what Mike was saying, because we, LONAP, also have multicast VLAN, and we don't have any PIM snooping, and our aggregate traffic is getting to the point where we're advising people on 100 meg ports not to use our multicast VLAN.
Yeah, nobody's using multicast at M6 as far as I can tell from our graphs.
Yeah, it's just interesting, the BBC and also
Yeah,
Virgin Radio.
Due to rights limitations, BBC, as far as I know, are not able to send their content to overseas areas.
They have a project, I think, for some more international, but hasn't really gone very far yet.
Well, they're welcome. They're more than welcome,
Yeah,
or anybody is.
I think that's one thing they're looking at is distributing content that they do have international rights for outside of the UK via multicast. So that might be an interesting development as time goes on. Okay, if there's no more questions.